Hi viewers, welcome to today's episode of Ulari Online Maths class. In today's video, we'll be solving the following questions. We have three different questions and they're all relating to the previous videos we've done. I made a video on how to find the derivative of inverse trigonometric functions. So today we'll be still, and we also recall that we made videos also on how to solve trig inverse functions with functions inside them. These are relating questions, and uh, sorry to say, my friends referred me to these questions, so we just have to do them again. So let's start from the first one. Solution. The first one being y is equals cos inverse of, okay, not x but square root of x this time around. Yesterday we did cos inverse of 2x, was it? Yeah. So in today will be, let's just go straight. We let u equals square root of x. Recall I said whenever you are picking your u, you make sure you pick what is inside the inverse function. So we pick square root of x because that's what is inside. Immediately you are done with picking your u, you find the u, the x, and normally what's our du dx? When you have to find the derivative of square root of x, this is something as x raised to power half, right? So to find derivative of this, recall the trick, bring down the power 1 over 2, right? Bring back the function x, remove 1 from the power. This is minus 1 over 2, which is 1 over 2 root x. That's our, if you differentiate square root of x, is going to be 1 over 2 root x. So that means this is something as 1 over 2 root x. Now, immediately you're done with finding your u and du, you go straight again. You said y is equals cos inverse of, instead of this, recall you said u is this, so I can replace the whole of this function with u. So I have cos inverse of u. Immediately you're done with that, you find your dy du, which is equals, recall that if you differentiate inverse cos, what do you get? You find minus 1 over square root of 1 minus, recall those ones we've been doing was x squared. This time around, this is u, so I'll put u squared, right? So we have our dy du as well. So sorry, I've not told you we are to use the chain rule as usual. So let me just write the formula again, just like how we did in the last video. Our chain rule, which is dy the x is equals, we have dy du times du dx. That's the formula. So this is the formula we'll be using now. We have everything we need to insert there. So our dy the x, which is what we need, is a derivative, is equals dy du. What is our dy du? This is minus 1 over square root of 1 minus, sorry, this is supposed to be u squared multiplied by du dx, which is 1 over 2 root x. So all in all, if we are to rearrange everything, this is, if you multiply this and this, I'm going to have minus 1 over 2 square root of x times square root of 1 minus u squared. This time around, we said u was square root of x, right? So they said squared. Look at what I'm to do. If u is equals square root of x, what is u squared? U squared is going to be square root of x all squared, right? So our u squared is going to be, this will go with this x. So in place of the whole of u squared, I'm to write x. You can actually stop here, but to just rewrite it in a simpler form, you just say minus 1 over 2 square root of x, open bracket 1 minus x. And that's the derivative of the first question, which is cos inverse of square root of x. So without wasting much time, let's just go straight to the second question. Okay. So the second question, which is y is equals, this time around, it's a sine inverse of x squared. Same idea, you just let u is equals, like I said, pick what is inside the inverse sign, which is x squared. differentiate u, which is du with respect to x, is equals 2x, right? So immediately you're done with u du, the next thing is to get your y to be equals sine inverse of, instead of x squared, I'm to write u. So what is our dy du? Our dy du this time, recall that if you differentiate the inverse sine function, you get 1 over square root of 1 minus, instead of x squared I've been using, we'll just use u squared. Please, in case you are still confused about how I'm doing all these inverse sine, inverse cosine, check my videos. I have videos on how to find the inverse sine, inverse tangent, and the rest. So proceeding with this, we have everything we need. It's just to use the formula to get the rest. Our dy, the x this time, is equals dy du. Dy du is 1 over square root of 1 minus u squared times, what is our du dx? Du dx is what? 2x, right? So I'll just write it. Just write this here. Dy dx is equals 2x over, if you multiply this, you're going to have square root of 1 minus, instead of u square, we said u was what? We said u is x squared. So instead of u square, we have to get x4, x raised to power 4. So this is also the derivative of the second question. So lastly, which is the third question this time around, which says y is equals tan inverse of 1 over 1 minus x. This looks a bit complicated, but calm down. We can clear this down. Just normally, you let u is equals the function inside the inverse tangent, which is 1 over 1 minus x. What is our du dx? Du dx this time around, you have to use what we call the quotient rule. I have videos on quotient rule as well, so you check it so you understand what I'm about to do here. When you have a quotient rule like this, the formula says, I don't know if we need to write the formula. Let me just squeeze this place, write it. For quotient rule, dy dx is just v du dx minus u dv dx over v squared. So that's the formula we're using because I'm having 1 over a certain function. So using the formula, what is our v? V is normally what is down, right? So v, which is 1 minus x. What is our du? V du is 0 because if you differentiate what is here, differentiating the constant, you get 0. Then minus u dv. U is 1. Then what is dv? If you differentiate v, you are going to have minus 1 over what is v squared. V squared is 1 minus x all squared, right? So this part is gone. Minus 1 minus 1. That's going to be 1. So, sorry, let me just write this. This is going to be a positive 1. Positive 1 over, open bracket, 1 minus x all squared. This is our du dx. So we have y right now is equals tan inverse of, instead of this, I'm to put u. So what is our dy du? If you differentiate tan inverse of u, you are going to have, recall, 1 over 1 plus u squared. So if this is our dy du, inserting in the chain rule, dy dx is equals, if you bring the formula dy du, which is 1 over 1 plus u squared, times what is our du dx? Du dx is 1 over 1 minus x all squared, right? So if you multiply this together, you are going to arrive with dy over dx is equals, we have 1 over, open bracket, 1 plus, instead of u squared, what did we say is u? We said u is 1 over 1 minus x. So I can just rewrite this inside 1 minus 1 minus x, right? But it's, everything here is squared. Sorry, I have to clear things down. This is 1 plus u squared, which is 1 over 1 minus x, but everything is squared. Then I still have something down, which is 1 minus x all squared. You can actually stop here. That's if you don't want to stress yourself, but you can actually just move forward if you like. You simplify things down here, and trust me, expanding this, you are going to arrive with something good. So for interested persons, let me just proceed. But if you are lazy as I am, you can just stop there. So the y dx is going to be, we have 1 over, this is a separate function. So we multiply this with this. Recall this, I'm having squared here. So I'm having, for this alone, I'll be having 1 minus x squared because I'm multiplying it by 1. Then we have plus, if you multiply this with this, it will cancel out. I'm having 1 down. I don't know if you understand. 1 times 1 minus x squared, I'm having 1 minus, sorry, this should be squared here. I'm having 1 minus x all squared, right? Then plus, if you multiply this with this will cancel out, remaining plus 1. This is it, which is 1 over, no need to expand, let's just leave it as 1 plus open bracket 1 minus x all squared. I'll stop here, and that's the answer. So thanks for watching, and anticipate more questions and solutions just like the one we've done before.